As the title screen says, we're going to talk about special right triangles today. Two special triangles, which are right triangles. And the reason we talk about these is because they pop up very frequently, and we're going to be forced to solve a right triangle given only one side. Obviously, if you're given two sides of a right triangle, you can always apply the Pythagorean theorem. This won't always be the case. So let's start with that question first. You'll need your calculators, by the way. And I think I'd like an exact answer. Even though that would make no sense. Oh no, it says to the nearest foot. Okay, let's do it to the nearest foot. I'm just kidding.
Give this measurement at a point.
You all know that a baseball diamond is actually a square, right?
Yeah.
It's not a diamond. That would be a rhombus. It's a square. Well, which is also a rhombus, but more specifically a square. I guess I'm assuming you all know baseball, do you?
I do.
Okay, so how far is it from home plate to first base?
90 feet.
90 feet, okay. That might be a necessary piece of information that you need.
Okay.
Hold on. 90 feet from home to first.
Yeah.
Nobody wants to comment on the picture of me from first grade?
Well, I was from
This you?
Yes.
grade
It's
4.
not me.
I was gonna say, I don't think that's you.
It's not me. I never wore those cool clothing. That cool clothes, I mean. The tight gray sweatpants with the black shoes and the striped shirt.
Wasn't your style?
All right, Rich, what do you got?
127.3 feet.
127.3 feet. How'd you get that?
I did a squared plus b squared equals c squared. Because.
Should we draw a picture first?
Yes, you should.
Okay, for those of you that are not very knowledgeable about baseball, home plate, first base, second base, third base. This distance is 90 feet.
That
Okay,
was
go
90
ahead.
feet.
This is 90 feet
Yep.
because they're all the same distance.
I like to draw a line between first or second and home because it just gives me a nice little visual. And then since the line from second to home was opposite the right angle of the square, then that was the hypotenuse. So I just plugged in the
What did you call this?
I called that x. And then I did 90 squared plus 90 squared is equal to x squared.
Well done. And x
that
equal?
came out to 16,200, and that would come out to x equals 127.3
0.3
feet.
feet. Good. Any problems there? Can you tell me about this triangle, Rich?
It is a right triangle.
Good. Anything else?
It is isosceles.
Good.
I can tell you the other
That
two
wasn't
angles
me.
are. I can tell you the other two angles are 45 degrees.
Good.
That's about all I got.
That's perfect. Unless Carter has something else.
Congruent to the triangle next to it.
Oh, that's a good call. There's 4.
That is true.
That's a
Yes.
good call.
Yes. Anything else? Okay, so this is either an isosceles right triangle, right? Isosceles because two of the sides are equal, right because it's got a right angle, or these angles are how big did you say?
45.
Why are they 45?
Because it's the entire baseball diamond is a square. So if you chop it right in half with the second to home, it would have to be both are equal angle.
How do you know it's chopped in half?
Because second to home is in half.
sorry, how do you know the angle, how do you know this angle is chopped in half?
Oh. Well. I don't know.
Josh?
Those triangles have to be the same because it's isosceles triangle.
Okay, one approach is this isosceles triangle, so ITT would make those angles equal. You got 90, 180 minus 90, 45 each. This, answering the question that I asked you, how do I know that angle is bisected? Because that's a property of a diagonal of a square. Okay, good. That takes care of that. 127.3 feet, and that gets us to this. The 45, 45, 90 triangle is the first special right triangle we're going to deal with. It's half of a square. So we took that square that was the baseball diamond, chopped it in half, and we get this thing. This is called the general form. So instead of using 90, 90, and 127.3, I'm making a general statement about a 45, 45, 90 triangle. The legs are A, and the hypotenuse is A square roots of 2. Now where did that A square roots of 2 come from? Well, we do a little bit of math and say, let's suppose we didn't know that, we just know the legs. A squared plus A squared is equal to this thing. Let's say the hypotenuse squared. What's A squared plus A squared?
2a squared.
2A squared. How do I get H by itself here?
Square root the whole.
Take the square root. Square root of 2A squared. Square root of 2 times, 2 times A. That's sloppy. Square root of 2. Or A square root of 2. We normally write the A in front so that you don't mistake the A being underneath the square root symbol. This is something you're going to want to know, because this is going to allow you to solve a whole bunch of 45, 45, 90 triangles. Notice there's only two sides of that triangle. You either have a leg or you have the hypotenuse. Okay, you with me so far? Unlike the baseball problem we did in the last screen, a normal 45, 45, 90 triangle problem will only give you one side. So, for instance, it's 466.7 feet between the two foul poles at Dodger Stadium. How far are the foul poles from home plate? Again, I don't want to assume that all of you know how baseball works, so I'll draw you a picture. Here's home plate. There's the first foul pole. There's the second foul pole. That's the distance we know. This is 466.7. I'd like to know how long those distances are. So we could do Pythagorean theorem. We could say x squared plus x squared equals 466.7 squared. But we'd like to solve it using a 45, 45, 90 triangle, because hopefully by now you realize this is an isosceles right triangle. These angles are equal. They're both 45 degrees. So that 466.7, is that the hypotenuse or the leg of the 45, 45, 90 triangle? It's the hypotenuse. How big is the hypotenuse in the general form?
A2.
A squared roots of 2. Solve for A. How do I solve for A?
Square.
How do I solve for A? No, not square. Divide.
Be mathy.
Little help? Anybody?
Multiply both sides by the square root.
No, just take a calculator and do 466.7 divided by square root.
329.63.
Does that answer make sense?
Yes.
Why? Nick?
Because those two, because A, 2A is greater than 466.
2A or just A?
Oh, A
Yeah.
plus A.
Oh, that's okay. One reason triangle inequality. The major point is that it's less than the hypotenuse, so we're good. Okay, and those are feet. So given a 45, 45, 90 triangle, you wanna ask yourself, which side do I know? Take that value, set it equal to the general form, solve for A. Now initially in the 45, 45, 90 triangle, this may seem like a little bit of overkill. But when we get to the 30, 60, 90 triangle, it's gonna be crucial. Okay, so our second type of triangle is the 30, 60, 90. We start with an equilateral triangle. Jack, what can you tell me about an equilateral triangle?
That all sides are equal and all angles are equal.
Good. And how big are each of the angles?
60.
And how big are each of the sides? Good answer. Well, you answered that already. They're each 60 degrees. Okay, so we're going to call it AA and A. Since we don't know the length of the sides, we'll just call it A, staying with that general form idea we had in the 45, 45, 90 triangle. Let's chop it in half. How long is that side?
Half A.
Half A. Okay, good. How long's the other side?
At 1.5 A.
Nope. That would make it a 45, 45, 90 triangle.
Oh.
You don't know? Can we find it?
Yes.
How? Faith? Say again? Okay, good. Tell me how I set it up. We'll call it X just for discussion purposes.
Okay, you can do 1/2 A squared
1/2 A quantity squared
plus X squared
plus X squared
equals A squared.
equals A squared. What's 1/2 A quantity squared?
How much is it? 1/2 A, is that it?
What's 1/2 A quantity squared, Emma?
Maybe
1/4
1/4 A squared.
A squared. Square the 1/2, square the A. We're solving for X squared. So X squared is equal to A squared minus 1/4 A squared. What's A squared minus 1/4 A squared?
3/4 A squared.
3/4 A squared. And how do I get X by itself? Take the square root of that whole mess. So the square root of that whole mess would give you the square root of 3 over 2A.
Wait, how?
What do you mean how?
How do you do that?
I took the square root of everything.
Yeah.
Square root of 3 is 3, the square root of 4 is 2, the square root of A squared is A. Are we good? So X is equal to the square root of 3 over 2A. How you guys feel about fractions? Meh? They're
I'd rather not.
You'd rather not have them? All right. Only because you asked so nicely, we can get rid of the fractions. So, we'll get rid of the fractions by doing this. Instead of starting with the side of the triangle being A, I'm going to start with it being 2A. That way, when I take half of this side, I get a nice number here, no fraction. When I do Pythagorean theorem, I get no fraction. That'll make your life a little bit easier, Zach. Just for you, buddy. General form of a 30, 60, 90 triangle. Pregunta.
Will that always work?
For a 30, 60, 90 triangle,
Yeah,
will
make
always...
it two-way on the hypotenuse.
Yes, sir. Well, you don't have to. I mean,
It'll be easy.
you could make the hypotenuse 8A, and then the short leg would be 4A, and then, you know what I mean?
Okay.
This is the easiest way to do it.
Okay.
Notice there's 3 sides to the triangle now. There's a short leg, there's a long leg, and there's a hypotenuse. You have to be able to identify each of those sides. Excuse me, the short leg, joking on my own spit. Excuse me. Oh. The short leg is opposite the 30-degree angle. The long leg is opposite the 60-degree angle, and as always, the hypotenuse is opposite the 90-degree angle. Okay, we ready? Here we, no? How about now?
Why is it A squared root 2?
Because A squared plus X squared equals 2A quantity squared. When you solve that, you would get that. Or I just took the previous problem that we did and multiplied everything by 2. Okay, here we go. Notice we can't use Pythagorean theorem because we only know one side. So question number one, what kind of triangle is that? Is it a 45, 45, 90 or a 30, 60, 90 triangle? 30, 60, 90. Which side do we know? Short leg, long leg, or hypotenuse? Hypotenuse. What's the length of the hypotenuse in the general form? 2a. Take the value from the triangle, set it equal to the value from the general form, solve for a. Not rocket science. Now that you know a, plug and chug. Which side is a?
Do you even have to do any equations?
Which side is a?
Oh, it's CA.
CA, correct. If that's 8, how long is this?
8 squared to 3.
8 square roots of 3. So once you have a, you plug and chug. Any problems? All right. Now, many of you were whining like, why do we have to set it equal? Blah, blah. You'll see as the problems get more difficult, it's going to get more confusing. Case in point, solve that. No decimal answers, exact answers only. What do you got there, Sparky?
Oh, I don't know how to do it without getting decimals.
For my exact answer, if I put 16 over, instead of the range, but I multiplied by 2, then how do I get my answer?
You don't have a calculator for that. We'll look at the worst side. Once you find a, then you just multiply. Question? Good. All right, what kind of triangle? 36 and 90. Which side do we know? Long side. And how long is the long side in the general form? I don't know what you guys learned in algebra last year, but in this class you don't have to rationalize denominators. It might later on, you might see that it'll benefit you if you do, but in this case we don't care. Which side is 16 divided by root 3? AC or AB? AC. 16 divided by root 3. Therefore AB is 2 times that. What's 2 times 16 divided by root 3? Emma. 32 over the square root of 3. Not 32 over the square root of 6. Not 32 over 2 square roots of 3. It's simple multiplication. Nick?
If you said the long leg is a root 3, but why did you get 16 over square root of 3 for AC?
Because that's A in the general form.
Oh,
This one.
So let's solve for A.
I'll come back. I gotta work on mine.
Okay. Got it? 3 scenarios. You know one of the 3 sides. Solve for the A value, then plug in chug. Try that one. Notice it says exact area. What 2 chunks of information do you need to find the area of a triangle? Base and height, what are we missing? The height, might want to draw that in. And then you just do area for 1/2 base on height. You did the hard work. You did the hard work. You've done the hard part, not the easy part. You didn't do it the hard way, you did it the right way. Gesundheit. What's the height of the triangle? Joe, spring a leak?
The square root of
6 right?
6 radical 3, correct. Why?
Well, you have to chop the 12 in half,
Right? So that bad boy is 6.
and then you know that if it's an equilateral triangle, then that side would be another 12. But-
Correct.
And then it'd just be 6 radical 3.
Why? What kind of triangle is this?
It's the 30, 60, 90.
30, 60, 90 triangle. We know the short leg is 6. We don't need that, but it's 12, and therefore the height would be 6 radical 3. And therefore the area of triangle is?
62.35.
No, but I mean the formula, sorry.
Oh, half base times height.
Half base times height. Lowercase b, lowercase h, that's important. 1/2. How long is the base?
12.
12. What's the height?
6 radical 3.
6 squared root of 3. So that's 36 root 3 meters squared. And then if you want an approximate value, you can plug that into your calculator and give it an approximate answer. But it did say it's looking for an exact answer. Okay, what part of that, where did I lose you on that one? Are we good? Even if you forget the 30, 60, 90 triangle or didn't try to use it, once you have the 6 and the 12, you can always solve for this using Pythagorean theorem. But in most of the 30, 60, 90, and 45, 45, 90 triangle problems, you're not going to have the luxury of 2 sides. You're going to have to either go find another side or use the formulas. Jock?
Would you do the half times 12?
Because I did the whole base, I found
Okay, you were
the
doing
entire triangle. You could have done 6 times 6 squared root of 3 times 1/2 and then doubled it.
Okay.
Same results. Yes?
So I get how it's like 6 times 6 root 3, but then wouldn't that be like 36 times square root of 8?
No. That's why we did a radical review. What's 3 square roots of 2 times 5 square roots of 7? How's it going? See? How's it going?
Be confident.
Yeah. Say it loud, say it proud. What's the answer?
15 squared root of 14.
15 square roots of 14. Numbers in front multiplied together, numbers underneath the radical multiplied together.
I get it.
Yeah, there's no distributive property with radicals. Okie doke.
Pretty radical.
Okay, so 6 steps. As you get better at this, you'll realize you don't need all 6 steps, and in fact, you can probably eliminate most of them. But again, what kind of triangle are you dealing with? Make sure you distinguish. Is it a 45, 45, 90 triangle? Is it a 30, 60, 90 triangle? Or maybe it's not one of the special right triangles. Once we start quizzing on this stuff, you can't assume that all triangles are going to be special. Number 2, what side do you know? In a 45, 45, 90 triangle, do you know the leg or do you know the hypotenuse? In a 30, 60, 90 triangle, do you know the short leg, the long leg, or the hypotenuse? Number 3, what's the value of that side in the general form? Number 4, set the 2 things equal. Set the value from the general form and the value from the problem equal to each other, solve for A. Then use that A to plug and chug into the entire triangle. Okay, so instead of making this really difficult, we're going to turn it into a fairly algorithmic approach here. If you follow the steps, it should be pretty straightforward. It doesn't seem like step 1 is very important, but it is, because some of you will try to use the special right triangle stuff on just a plain old right triangle, or just a plain old triangle that's not even right. And then that just gets crazy out of control. We don't want that. All right, we good? All right. That's all I got for you.